my PU2 students, so I hope all of you are preparing really well for your chemistry examinations. You are working hard and studying day and night. So today we are going to revise the final revision of physical chemistry and inorganic chemistry. So yesterday I have already given you 1 marker questions and the numerical questions. So today we will be tackling that section B and C of the question paper where we will be getting 2 plus 3 markers. So that is what I am going to discuss. Almost 100 plus questions have been discussed. Quickly revise these questions and you are ready to attempt section B and section C perfectly. Okay, so sorry. Okay, so now if you see the questions, okay, here a small typing error. So we have D and F block and coordination compounds. We have solutions, kinetics and electrochemistry. So let us quickly go through the first question, that is solutions. So these questions I will just take you. I have taken from your PU question bank, okay, the most important resource now from previous year questions and from your NCERT book. So what is saturated and unsaturated solution? What is the effect of temperature and pressure on the solubility of solids in a liquid? So saturated solution means the solution where you cannot dissolve any other further solute, and unsaturated solution means where you can dissolve further solute in the solvent. Next, effect of temperature and pressure. So it depends if the dissolution process is endothermic or exothermic. If it is endothermic, more temperature, more solubility. If it is exothermic, lower temperature, more solubility. And pressure has no effect on the solubility of solid in a liquid. Okay, so these are very easy question. You can see where no more solute can be dissolved. Some more solute can be dissolved at the same temperature. If endothermic, then increase of temperature will increase the solubility. If exothermic, then decrease on increasing of temperature. Pressure has no effect. Okay, I have given the answer in key points so that, but you have to write the answer in by framing sentences. Okay, next, what is molarity? How does it vary with temperature? And write its SI unit. So molarity is the number of moles per unit liter, or you can say number of moles of the solute present in 1 liter of the solution. So therefore molarity depends on the volume of the solution, right? If you see the formula for molarity, it is equal to number of moles by volume. Okay, now it depends on the volume. Now if you see the volume of the solution depends on temperature, or it changes with temperature, so that is why it also changes with the, so if temperature changes, molarity will change. Why? Because volume is also changing. So volume of the solution varies with the change in temperature, hence the molarity of a solution depends upon the temperature. What is the unit of molarity? Number of moles is moles and the volume is liter. Okay. Next, we have mentioned the factors on which the solubility depends. So you can write any 3 factors. We have nature of the solute, nature of the solvent, pressure and temperature. Moving to question number 4, state Henry's law and write its mathematical term, and what is the significance of KH. So Henry's law states that at a constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or the solution. Now P is equal to KH of and gas. So here you can mention the terms. This is very important. P of the gas is what? Partial pressure. Okay, partial pressure of the gas. KH is Henry's constant. Okay, and mole fraction, X of the gas is mole fraction, right? Now what is the significance of KH? So higher is the KH value, lesser is the solubility. Okay, now if I see at a given temperature and pressure, N2 is more soluble than helium in water. If more soluble, less KH value. Whose KH value will be more? Helium is less soluble, so its KH value will be more. Next, aquatic species are more comfortable in cold water than in hot water. So the solubility of a gas in a liquid is inversely proportional to temperature, means if the temperature increases, solubility will decrease for solubility of gas in a liquid. Now in hot water, less amount of oxygen will dissolve. In cold water, more amount of oxygen will be dissolved. So aquatic animals require dissolved oxygen, right? So that is why in cold water there will be more amount of oxygen, and that is why the aquatic animals are more comfortable in cold waters. I hope this is clear. So you can see here, first of all, it is helium. Now solubility of a gases increases with the decrease in the temperature. As in cold temperature, more amount of oxygen is dissolved, so the aquatic species are more comfortable. Okay, this was a reasoning question. It can be asked. 3 applications of Henry's law you can mention: the carbonated beverages, in scuba divers, and in the higher altitude, the medical condition, that is your anemia. Okay, you have to explain it in these points, in small points you can write down. Okay, next. Okay, why do gases always tend to be less soluble in liquids as the temperature is raised? So just now I tell you. So what happens when you increase the temperature? The gaseous molecules will get kinetic energy, right? So they will vibrate more rapidly and they will try to escape from the liquid. Okay, so they will not remain in the liquid, they will escape from the liquid, or they will go to the vapor phase, or they will go to the gaseous phase. So that is why basically what happens when you increase the temperature, the gases becomes less soluble. How can we write that? See, the solubility of a gas in a liquid at a particular temperature is directly proportional to the pressure of the gas in the equilibrium with the liquid at that temperature. So first of all, we have seen the Henry's law, solubility is directly proportional to pressure. Now the dissolution of a gas in a liquid is an exothermic process. This is very, very important. The dissolution of solid in a liquid can be exothermic or endothermic, but the dissolution of the gas in a liquid is always exothermic. Okay, so it is accomplished by the evolution of heat. Thus the equilibrium is like this: gas plus solvent, it is solution plus heat. Now according to Le-Chatterley principle, the increase in temperature would shift the equilibrium in the backward direction, that is the solubility would decrease. Therefore gases always tends to be less soluble in liquid as the temperature is raised. Okay, you can write down this answer, very well written, like this you can present. Explain the cause of bends in scuba diver and how it is controlled. So let me explain you quickly. When the scuba divers go down, deep down the ocean, okay, pressure is increasing, solubility of nitrogen into the blood will increase. Now when the scuba diver comes to the surface of the water, okay, when they come out, pressure is decreasing, solubility will decrease. So the gas, the nitrogen gas which was dissolved in the blood of the scuba divers comes out in the form of bubbles. Now this can block the arteries, veins, and can cause severe pain to the scuba divers, which is called as your bends. How do we solve it? We add some helium. Around 11.7% of helium is added to the oxygen cylinder of the scuba divers. Now just now we saw in a previous question that helium is less soluble. So if helium is less soluble, it won't go to the blood, right? And that is why the problem is solved in this way. So you can see here, I have written it in detail. As scuba divers go down the sea, the pressure increases under the water. Increased pressure increases the solubility of the nitrogen in the blood. When the divers comes to the surface, the pressure gradually decreases, and this releases the dissolved gas and leads to the formation of bubbles of nitrogen in the blood. This blocks the capillaries and create a medical condition as bends, which is painful and dangerous to life. So to avoid the bends, the tanks used by the scuba divers are filled with helium 11.7%, please remember, nitrogen 56.2 and oxygen 32 because of the low solubility of helium. Why do we use helium? Because it has very low solubility. Okay, next. Question number 9, state Raoult's law and give its mathematical form. What is vapor pressure? Vapor pressure of CH-Cl3 and CH2Cl2 are given, which is more volatile. So Raoult's law is what? According to Raoult's law, if you have a solution of two volatile liquids, okay, the partial pressure of the component is directly proportional to the mole fraction of the component in the liquid. So for example, you have a solution here A and B. Okay, both are volatile. A will evaporate, B will evaporate. Partial pressure of A will be created, partial pressure of B will be created. So the point here is the partial pressure of A is directly proportional to the mole fraction of A in the liquid. If more A is present, more vaporization will take place. So that is why the partial pressure of A will be higher. That is very simple, right? But they have given you in the term of a law. Okay, but this is very common sense thing. If you have more A will evaporate, so that is why partial pressure of A will be more. If you have more B will evaporate, the partial pressure of B will evaporate. So that is what the condition or the law says, that when in a mixture of two volatile liquids, the partial pressure of a you can say liquid is directly proportional to its mole fraction in the liquid. Okay, so how can we represent it? it states that in a solution of two volatile liquids, the partial pressure of each component of the solution is directly proportional to its mole fraction. Okay, so I just want to write here the mathematical term P is equal to P naught, you can just write down like this, into XA. Okay. Next, what is vapor pressure? The vapor pressure exerted on the liquid by the vapor present above the liquid surface when they are in equilibrium with the liquid is called as vapor pressure. Okay, so you have liquid, they undergo evaporation, there is a pressure created there. So that pressure which is exerted by the gas vapors on the liquid is called as your vapor pressure. Next, here we have CHCl3 is 200 and CH2Cl2 is 415, right? So that means whose vapor pressure you are seeing more? CH2Cl2, right? 415. That means what? More CH2Cl2 has evaporated and has created a vapor pressure. So which is more volatile? Obviously CH2Cl2. So that will be more volatile. Next, why is vapor pressure of the solvent decreases on addition of a non-volatile solute? This is very important question. See, vapor pressure, how is it created? You should have a closed container. See, you should have a closed container. Okay, here this solvent molecules are present. This solvent molecules evaporate, right? When the rate of evaporation and the rate of condensation becomes equal, there is some vapors produced here. Okay, and the pressure exerted by these vapors on the liquid is called as vapor pressure. Now suppose I add a solute in this. So what will happen? Some of the particles on the surface will be the solute one, right? So earlier I can say 1, 2, 3, 4, 5, 6 molecules were evaporating. Now when I added solute, only 3 particles can evaporate, right? So if only 3 particles will evaporate, then definitely the vapor pressure will be low, right? So that is the reason why the vapor pressure decreases on adding the solute. So you can see in a pure just a minute, yes, in a pure liquid the entire surface is occupied by the molecules of the liquid. If a non-volatile solute is added to a solvent to give a solution, the vapor pressure of the solution is solely from the solvent alone. Now the solute is non-volatile, it will not evaporate, right? It will not have any contribution to the vapor pressure. So it is only the solvent molecules which will create the vapor pressure. So in the solution, the surface has both the solute and the solvent molecules, thereby the fraction of the surface covered by the solvent molecule gets reduced. Earlier if it was 100%, now it has reduced because some of the surface molecules are now solute particles which will not evaporate. So that is why the number of solvent molecules escaping from the surface is correspondingly reduced, thus the vapor pressure is also reduced. Okay. Next, ideal and non-ideal solution, give examples. So this you can easily write down. Okay, so ideal solution is something which obeys the Raoult's law. Example you can write down here, any other example is also fine. And the example, the graph for your ideal solution, that is your vapor pressure versus mole fraction, the graph is like this. You should be knowing x, so 1, 2, all the leveling should be done and properly it should be done, dotted line, solid line. So please see this graph properly. Next we will see non-ideal solution example and graph. So which does not obey Raoult's law. Non-ideal solution can be positive and negative deviation. We'll do that question later. So here are some examples of non-ideal solution, and if I show you the graph, so you have to draw for both positive deviation and negative deviation graph. Okay, so please watch this graph properly and do it. Difference between ideal and non-ideal solution, see the points here, obeys Raoult's law, does not obey, delta H mix 0, not 0, V mix 0, not 0. Here interactions are equal, interactions are not equal. And one more point you can add is your fifth point you can write, which is your examples. Just now I have written, right? Example you can write here N-hexane plus N-heptane. Okay, here you can write down ethanol and acetone. Okay, now coming to the next one, that is your different type of non-ideal solutions, we have positive deviation and negative deviation. So generally what happens, see, you have one solution A, you have one solution B. A will have AA interaction, B will have BB interaction. Now when you mix them, they will have AB interactions. So if this AB interaction is stronger than AA and BB interaction, means what? They will get more closer, the bond will increase more, the intermolecular forces will increase more, okay? Then they will not evaporate easily because their interactions has increased now. So what will happen? The vapor pressure will decrease, and that is why it is a negative deviation. Now if you have added A and B, they are not good friends, right? They are repelling from each other. So the interactions is very weak, so they will easily evaporate and they will cause positive deviation. So in that case, positive deviation, weak interactions, negative deviation, strong interactions. And here you can write total pressure will definitely be here more because the weak interaction is there, more evaporation will be there. Here total pressure will be low. Mix positive, it is negative. Example, ethanol plus acetone, CS2 plus acetone. It is phenol plus aniline and chloroform plus acetone. Okay. Next we have give the type of deviations with the reason. So first is your acetone and ethanol. So you know in ethanol we have strong hydrogen bonding, but when you add acetone to that, the bonding is disrupted. So it is a positive deviation. Phenol and aniline can have strong hydrogen bonding, so it is a positive deviation. Again, sorry, it is a negative deviation. So this one is positive, this is negative. Then chloroform acetone can also have strong intermolecular forces, so that is also negative deviation. Okay, so you can see here in positive, why? Because in pure ethanol molecules are hydrogen bonded, but when you add acetone to it, the hydrogen bonded between the ethanol molecules break. Okay, next we have negative deviation. So this is because the intermolecular hydrogen bonding between the phenolic proton and the lone pair of nitrogen is stronger. Okay, you can see a strong hydrogen bonding there. And then chloroform and acetone, this is because chloroform molecule can form hydrogen bond with acetone molecule. Okay. Next, what are azeotropes? Give an example, mention the type of azeotropes. So those liquids which cannot be separated, which boils together, have a constant boiling point and cannot be separated by steam distillation is called as azeotropes, right? So binary liquid mixture having the same composition in the liquid and the vapor phase and boil at a constant temperature is called as your azeotropic mixture. Here we have 95% of ethanol and 5% of water. And type of azeotropes, maximum and minimum boiling azeotope. Difference between maximum and minimum boiling azeotopes. So you can see maximum boiling azeotope means they will boil at a higher point. So their interactions is very strong or they will show negative deviation. Minimum boiling point, they have weak intermolecular forces, so that is a positive deviation. Now here you can see they boil at a temperature higher than the constituent boiling point. Here they boil at a temperature lower than the constituent boiling point. Next example, nitric acid and water, ethanol and water. Please mention the constituents, the percentage also should be clearly remembered. Okay. Next we have what do you mean by colligative properties and name them. This is very simple. Colligative properties are what? Those properties which depends on the amount or the number of solute particles and not on the nature of the solute particles. Okay. Examples are RLVP, relative lowering of vapor pressure, elevation in boiling point, depression in freezing point and osmotic pressure. Okay. Next, when does liquid boil and what is the ebullioscopic constant and what is its SI unit? So liquid will boil when? See, liquid will have a vapor pressure. When this vapor pressure is equal to the atmospheric pressure, at that time the liquid will boil and that temperature is called as your boiling point. Next, what is the ebullioscopic constant? Ebullioscopic constant is your Kb value and what is its SI unit? So let's see quickly here. So liquid boils when the vapor pressure of the liquid is equal to the atmospheric pressure. It is the increase in the boiling point produced when 1 mole of a non-volatile solute is dissolved in a pure solvent. Okay. Then we have the SI unit is Kelvin kilogram mole inverse. So if you see, we have delta TB is equal to Kb into M, right? If this is 1 molar, okay. So the increase in the boiling point or the rise in the boiling point, okay, when 1 mole of a solute is dissolved in 1 kg of the solvent, that is your ebullioscopic constant. Okay. Next we have give the relation to calculate the Kb using the enthalpy of vaporization. Draw the graph of vapor pressure with temperature to show the elevation in boiling point which has higher boiling point. Okay, so the graph part you can see here. I hope this is clear. See, this is the vapor pressure of the solvent. Okay, sorry, one second. Can I use a laser point to explain? Okay, so this is the vapor point of the solvent, okay, and this is what? This is the vapor point or the vapor pressure or the atmospheric vapor pressure. When the solvent vapor pressure meet the atmospheric vapor pressure, okay, just a minute. I will come back to my own style, that is of using pen. Okay, so now this point where the vapor pressure of the solvent meets the vapor pressure, the atmospheric pressure, that is called as your boiling point. Okay, now you have vapor pressure of the solution, okay, which is low. Why? Because we have added a solute. So when this one will meet, the vapor pressure, the boiling point has increased here. Okay, so next, give the relation to calculate the enthalpy of vaporization and this one. So you can write like this, Kb is equal to m r T naught B square by delta H fusion into 1000. Okay, m is your molar mass, r is gas constant, Tb is the boiling point of the solvent, sorry, not fusion here, vaporization, okay, into 1000. Next, which is having higher boiling point, so here you can see I value is 2 and here I value is 3, right? I is your Van 't Hoff factor. We have this formula like this, right? Delta Tb is equal to I into Kb into m. Molar, the concentration is same here. Kb will be same because both are your aqueous solution. So I value is more from here, so that definitely the boiling point will be higher here, 0.01 m Na2SO4. Okay. Okay. Next, when does the liquid freeze and why? What is the cryoscopic constant? What is its SI unit? Okay. So the same way we can answer, liquid will freeze when the vapor pressure of the liquid is equal to the vapor pressure of the solid. Next, what is the cryoscopic constant? So similarly, when the depression in freezing point, okay, it is decrease in the freezing point produced when 1 mole of a non-volatile solute is dissolved in 1 kg of the pure solvent. And what is its SI unit? The same, Kelvin kilogram mole inverse. Okay, here some questions. Scuba divers fill their air cylinders with dilute helium. The reason we have already discussed, because helium has less solubility into the blood, so that is why it can prevent bends there. Next, addition of small amount of salt in water decreases its freezing point. Yes, when you add a small amount of salt, the vapor pressure decreases, right? As a result, I'll explain in the graph, it will be more clear. The I value of KCl is more than that of ethanol in benzene. So KCl dissociates, whereas ethanol will not dissociate. So here I value is 2, here the I value is 1. Okay, let us see the answer here. So first of all, why we use helium in the oxygen tanks? Because of its less solubility than nitrogen in the blood. Next, this is very important question. Please understand here. See, you have the like this. This is the vapor pressure of the solvent, liquid. This is the vapor pressure of the solvent, solid. Okay. Now, when these two will meet, this is your freezing point, that is T naught F. Okay. Now, what happens? You have one more, that is vapor pressure of solution. Okay. Now, this one will come here. When this one will meet, this is your TF. So, what happens? When you have added a solute, the vapor pressure of the solution has decreased. So, when will this meet this one? That is your TF value. So, you can see here a solution will freeze when its vapor pressure equals to the vapor pressure of the pure solid solvent, right? Now, according to Raoult's law, when a non-volatile solute is added to the solvent, its vapor pressure decreases and now it would become equal to that of the solid solvent at a lower temperature. You can see it will become equal to the solid solvent at a lower temperature, and that is why the freezing point decreases on adding a solute. And next one is was your I value. So, KCl will dissociate and the I value is 2 here, and ethanol is a non-electrolyte, does not dissociate and its I value is 1 here. Okay. I hope this is clear. Next, Give the relation to calculate Kf using the enthalpy of fusion. Draw the graph of vapor pressure with temperature to show the depression in freezing point. Give reason to clear snow covered road and hills salt is added. This is very simple. First of all, enthalpy of fusion, if you see, just like the other formula, it is also there, mRTF square divided by delta H of fusion into 1000. Okay, next graph is here. I have already explained this graph. Next, why salt is used? See, when salt is sprinkled on the snow covered roads and hilly areas, the snow starts melting due to the depression in freezing point. So when you have added, it will decrease the freezing point, right? So the temperature which is present now is not the freezing point, so that's why the snow will melt. If you go to the lower temperature, at that temperature it will freeze. Now it will not freeze. So as a result, the formation of water takes place, which helps to clear the roads. Next, what is osmosis? Give an example. What is semi-permeable membrane, and give example for the natural and artificial membrane. So flow of the solvent molecules from lower concentrated solution to higher concentrated solution is called as osmosis. Membranes which allow only the solvent particles are called as semi-permeable membrane. Here we have natural is your pig's bladder or parchment membrane, artificial is your cellophane. Okay, so examples you should remember can be asked in the question. Next, these are all osmosis applications, so many questions can be asked. Raw mango shrivel when pickled in brine solution. So if you have taken a raw mango and you have taken a salt solution, then it will shrivel. Why? Or you can say it will shrivel, sorry. Why? Because osmosis will take place, right? Inside the mango there is more water and outside there is less water, so water will flow out, mango will shrivel, that is because of osmosis. Similarly, blood cells collapse when suspended in saline water. Same thing, when you put it in saline water, water will flow out, the blood cells will collapse. Wilted flowers revive when placed in fresh water. Fresh water you have kept, wilted flowers are there, they have less concentration, here high concentration, so water will flow inside the flowers and they will bloom, right? So that is what is the different application. So this is due to exosmosis, this is also due to exosmosis and due to endosmosis. What is exosmosis? Exosmosis means coming out from a particle, water coming out from the particle. Endosmosis means water entering inside the particle. Okay. Next, what is isotonic solution, hypertonic solution and hypotonic solution? Two solutions having same osmotic pressure is called as your isotonic solution. Okay. Next, what is hypertonic? The solution, if the solution of one of the compound, that is solution whose osmotic pressure is higher than the given solution, that is called as hypertonic solution. And similarly, what is hypotonic solution here? The solution whose osmotic pressure is higher, sorry, this is lower. Okay, just a minute. This is lower, then it is called hypotonic. Okay, yes. So these are the examples. You can see our blood cell. Okay, the RBC is isotonic with 0.9% NaCl. Okay, so the osmotic pressure of 0.9%, NaCl and RBC is same, so that is why they are isotonic. Next, we have what is edema, what is the cause of movement of water from soil to plants, preservation of meat by salting and of fruits by adding sugar, protects against bacterial infection, explain. So these are all applications of osmosis. Edema is what? See, when you take a lot of highly salt concentrated food, okay, the salt concentration of food is very high, then what will happen? You can see that your cell will be concentrated. Okay, so water will flow in, so because outside it is less concentration and your cell is high concentration, so water will flow from less concentration to high concentration and your cell will become bulky, or you can say it will swell. Okay, and that causes edema. Next, cause of the movement of water from soil to plants, again due to osmosis. Preservation of meat by salting. So when you salt this meat and fruits, okay, if any insects or any bacteria comes to that, they will immediately lose their body water. Why? Because outside there is less concentration, inside they have, sorry, outside there is high concentration, inside they have less concentration. So solvent molecules will move, so they will lose the water, and that is why they will shrivel and they will die. Okay, so you can see here People taking a lot of salt or salty food experiences water retention in the tissue cells and intercellular spaces because of osmosis. This results in the puffiness or the swelling called as edema. Now, through the process of osmosis, a bacterium on salted meat or candied fruit loses water, shrivels and then dies. Okay. Next, what is osmotic pressure? Give equation. And what is reverse osmosis? So, the external pressure that is required exactly to stop osmosis is called as your osmotic pressure. Okay, and when a pressure more than the osmotic pressure is applied on a concentrated solution, solvent flows from concentrated solution to the dilute solution through a semi-permeable membrane, and this is called as your reverse osmosis. Here equation is equal to, I'll just write down the equation for osmotic pressure here, pi is equal to CRT. Please mention the terms. C is concentration, R is gas constant and T is temperature, pi is osmotic pressure. Okay. Then explain the desalination of water by reverse osmosis and name the semi-permeable membrane used in this. Okay. So, what happens? Desalination of water, when you add more pressure, pressure more than osmotic pressure on the desalinated water side, pure water from this will squeeze out and flow towards the higher concentration side. Okay, will flow towards the lower concentration side. So, I will show you a diagram here that will be more clear. So, you can see here, this is your salt water. When you give pressure more than osmotic pressure, pure water from this will start flowing out and can be collected here. That is called as your reverse osmosis, and it is used for desalination of water. So, you can see reverse osmosis is used in the desalination of seawater when a pressure more than osmotic pressure is applied to the seawater. Pure water is squeezed out of the seawater through the semi-permeable membrane. And what is the semi-permeable membrane used in this? It is cellulose acetate. Okay, fine. Next, why osmotic pressure is used to calculate the molecular mass of polymers. You can see here that it is used. Why? Because first of all, it uses molarity instead of molality. Second, it can be measured at room temperature. And the third one here, the magnitude is very large and it is compared to other colligative properties. Like you can find the difference, a significant difference values can be calculated, and that is why it is used to calculate the molecular masses of macromolecules. Okay. So, next, what is abnormal mass and what is Van 't Hoff factor? What is the conclusion drawn when the Van 't Hoff factor of a solution? Okay, I think this question is incomplete. Let us see this one. What is abnormal molar mass? Okay, the molar mass determined by the colligative properties is found to be lower or higher than the expected normal molecular mass. Such a molecular mass is called as abnormal molecular mass. Now, why does this happen? This happens because when the solute either associate or dissociate. Okay. Next, what is Van 't Hoff factor? It is the ratio of normal mass to abnormal mass. Here are the different formulas of Van 't Hoff factor. You can use them, and the most commonly used formula is this one, right? Next, give reasons. Cutting onions taken from the fridge is more comfortable than cutting onions lying at room temperature. Yes, what can be the reason for here? Very, very simple thing. See, when you increase the temperature, the vapor pressure, the evaporation will increase, right? So, at a room temperature, what happens? The vapors of the onion liquid, which creates tears in our eyes, are more easily evaporating, okay, and it reaches our eyes and we feel the burning sensation and we get tears. But if it is in cold temperature, right, the evaporation rate will be very slow. So, that is why we can easily cut refrigerated onions than the onions in the room temperature. Next, when fruits and vegetables are dried and placed in the water, they slowly swell and return to their original form. This is due to endosmosis. Okay. So, you can see here at lower temperature, the vapor pressure of the tear producing chemicals is lower, meaning fewer of these volatile compounds escape into the air and irritate the eyes. Next one, the cell walls of the fruit and vegetables act as a semi-permeable membrane. When they are dried, concentrated inside becomes higher. On placing in the water, the process of osmosis takes place, so they swell and return to their original form. Okay. Next, why do electrolytes shows abnormal molecular masses? Name the factors responsible for abnormality. So, when an electrolyte is dissolved, it will dissociate, right? It will dissociate into its constituent ions. This increases the number of solute particles that is added. Now the number of more solute particles than expected leads to an increase in the colligative property of the solution. So this increase in the number of particles affect the calculation of the molecular mass, leading to what is termed as abnormal molecular mass. Now what factors affecting, either it can be association or the dissociation of the solute particles, very similar to the question that we have discussed. Now moving to the next chapter, chemical kinetics. What are the main criteria of effective collision, right? This is very important question. Many of the pre-board papers have this question. So first one is your activation energy and next one is your proper orientation. Okay. Next, what is collision frequency? Two drawbacks of collision theory. So collision frequency is the number of collisions per unit second and per unit volume. Direct definition based question, nothing to be explained here. Next, what are the drawbacks? The first drawback is in collision theory, the reactant molecules are considered as hard spheres. Their actual structure is not considered, the first thing. Okay. Next one is only kinetic energy of the molecules are considered, not their rotational energy, vibrational energy. These all energies are not considered, only the kinetic energy is considered. Okay. Next we have, write the Arrhenius equation, state what the different symbols stand for. So we have Arrhenius equation, K equal to A into e to the power of minus EA by RT, and here K is your rate constant, A is your frequency factor or Arrhenius factor, EA is your activation energy, R is gas constant and T is absolute temperature. Okay. Next we have, explain the effect of catalyst on the rate of a reaction. So generally what happens, a catalyst increases the rate of the reaction by decreasing the energy of activation or by providing a new reaction path for the reaction. Okay. So you can see here we have like this, this is the rate of the reaction, or this is the graph of the reaction when there is no catalyst, and when we use catalyst the activation energy decreases, and that is why the rate of the reaction increases. Next, give two properties of the catalyst among spontaneous and non-spontaneous reaction. Which one is catalyzed by catalyst? So two properties of catalyst is what? They does not alter the Gibbs energy and they do not alter the equilibrium constant. Okay, that are the two properties. What, which one will they catalyze? They will obviously catalyze the spontaneous reactions. They do not catalyze the non-spontaneous reactions. Okay. Next we have here, using the energy distribution curves showing temperature dependence of the rate of the reaction, explain the effect of temperature on the rate of the reaction, or plot Maxwell-Boltzmann distribution curve and mark the position of EA. So the same graph you have to do in all the both the cases. So you can see here the fraction of molecules and energy. So this was when temperature was T. When you increase the temperature, the graph became like this. So this, the particles which lie on this side can actually react or can actually form the products. So you can see that when you have temperature T, only this white section of the particles are having energy more than the threshold energy, and when you have increased the temperature, this whole part, this whole part is having now energy more than the threshold energy, and all of them can react. So the number of molecules, the fraction of molecules having energy greater than the threshold energy, okay, the number of particles or fraction of molecules having energy greater than the threshold energy at temperature T plus 10 is more. So definitely that is why the rate of the reaction is higher. So how can we write it? The peak of the curve corresponds to the most probable kinetic energy. When the temperature is raised, the maxima of the curve moves to the higher energy side such that there is greater proportion of molecules with much higher energy. This is not required in this exam, you can just write down this one. Increasing the temperature of the substance increases the fraction of molecules which collide with energy greater than EA. Okay. Now it is clear from the diagram that in the area A dash, B dash at T plus 10, showing the fraction of molecules having energy or greater than activation energy gets doubled, leading to the doubling of the rate of the reaction. Okay. So when you increase the temperature, the number of particles having energy greater than the threshold energy increases. So that is why definitely the rate of the reaction will also increase. Next, zeroth order reaction, give an example. So you can write any one. I have given you 3 examples, any one you can write down here. And what is zeroth order reaction? This type of reaction where the rate of reaction does not depends on the concentration. Okay, the rate of the reaction is independent of the concentration of the reactant is called as your zeroth order reaction. Similarly, first order reaction, rate of the reaction is proportional to the first power of the concentration of the reactant is called as your first order reaction. Examples are many, you can write any one. Next, pseudo first order reaction. So when you have higher order reactions are there, but they are actually converted to first order by when one of the reactant is present in excess. Okay, the higher order reactions can be converted into first order reactions by when one of the reactant is present in excess, that is called as your pseudo first order reaction. And you have 2 examples, one is your inversion of sugar and another is your acid hydrolysis of esters. So students, this is just now we are recalling all the concepts. I am not going very detailed in explanation. Okay, you just have to read these questions, learn these answers, understand it, and then go and write in the exam. So please don't expect me to explain all the questions at this point of time, because we are just left 2 days before exam and it is time to do question practice. Okay, so I'll be just giving you the list of questions, explaining wherever it is required. Now you have to solve these questions, practice these questions. Okay, fine. Next, what happens to half-life time of a first order reaction when the temperature is increased? Give reason. What happens to the half-life period of a first order reaction if the initial concentration of the reactant is increased? Okay, so if you see the T half of a first order reaction, okay, T half of a first order reaction is 0.693 K. Okay, now if you increase the temperature, K will increase, and if K will increase, half-life will decrease. And concentration, you can see the T half is, there is no dependency on concentration. So whatever you change in the concentration, the T half will not change. Okay, so you can see here that T half decreases as the temperature increase, because K is proportional to T and T half is proportional to 1 by K. Next, no change or remains constant. Okay. Next, how do you calculate the activation energy from Arrhenius equation by graphical method? This is important question. How can we use or calculate the activation energy? So if I have this Arrhenius equation, this is my Arrhenius equation. If I write it in terms of log, then I'll get log K is equal to log A minus EA by 2.303 R into 1 by T. Now the plot of log K versus 1 by T gives us a straight line with a slope of minus EA by 2.303 R. Okay, so it is a straight line, or a slope is a negative slope with minus EA by 2.303 R. Now by calculating the slope from the graph, energy of activation can be also calculated. So you can see here, if I just draw this graph and I calculated the slope of this graph, then slope is equal to minus EA by 2.303 R. So multiplying this one here, I can calculate the activation energy. Okay. Next, we have derive an expression for the zeroth order reaction. So I will not be explaining this one in much detail. We already know. The only thing that I want all of you, you can see the complete derivation here. Take a screenshot or write down here. So, but the only thing that I want to remind you is, in the derivation, you do not use A to B. You have to always use R gives P. Okay, that is a guideline from the examination board also. R gives P should be mentioned. So initially what we have to do, we know that rate is equal to minus dr by dt, right? And we also know that rate is equal to K into R. Okay, according to rate law and according to differential equation. Now if I equate these two, I'll get minus dr by dt is equal to K. Now you can just multiply dt on this side, I'll get this equation. Integrate it both sides, you will get R is equal to minus KT plus I. Now what happens to calculate the value of I? Take T is equal to 0 and R is equal to R naught. Substitute it, find the value of K, and you will get R naught minus R divided by T. Okay. Next we have the integrated equation for first order. Okay, similarly only we have to do it. First you can see minus dr by dt is equal to kr, and minus dr by r is equal to k dt. Now here if I take this one, I will get ln r is equal to minus kt plus I. Then you calculate at t equal to 0 and r is equal to r naught. What is the initial concentration? You will get ln r0 is equal to minus k0 plus I. I value you can find out here. then you will get ln r is equal to minus kt plus ln r0, then convert it into log and you will get here. Here also you should remember it should be in the form of r gives p. Do not write a and b here. Okay. Next, derive the integrated equation for first order gas phase reaction. Yes, here you have to use a and gives b plus c. Okay, so I will be explaining how can we do this. So I can write like this. Let us consider a reaction. Okay, I'm using certain shortcuts, but please do not use that. Write the complete words. Okay, a gives b plus c. Okay, let the initial pressure, okay, I'm just writing P, initial pressure of A be Pi. Written this one. After time t, let X amount of A has reacted. I'm just mentioning first all the terms. Okay, let Pt be the total pressure after time t. Okay, mentioned all the points. Now let me write down the equation. A equals to b plus c. Okay, so initial pressure I can write T equal to 0 was Pi. This one is 0, this one is 0. At time equal to t, X amount has reacted, so Pi minus X, X and X. Then I told you total pressure, P total, okay, or you can write it as PT like this. Okay, so PT or the total pressure is, I will add all this, it will give Pi plus X. Okay, what is the value of X here? X is equal to PT minus Pi. Okay, X is equal to PT minus Pi. Clear? So now what will happen here? I can calculate that pressure of A at time t. Okay, so that is what? Pi minus X, and that is equal to Pi minus X value is Pt minus Pi. Okay, and that will give me 2 Pi minus Pt. Okay, pressure of A after time t is 2 Pi minus Pt. Now I can substitute the K value, that is 2.303 by T log of initial pressure of A, I'm just writing like this, by final pressure of A. Or let me just write down like this, Pi by Pf. Pi by Pf. So I will get here 2.303 by T log of Pi, and Pf is 2 Pi minus Pt. Okay, clear? Okay. Next, 16th, derive an expression of half-life period of a 0th order reaction. So this is very simple. We already have this equation, right? This is Kt equal to R naught minus R. So during half-life, R value is R naught by 2 and T value is T half. So you have T half value here and substitute everything, you will get T half is equal to R naught by 2K. Okay. Next, question number 17, we have, similarly you have to show the half-life period for a first order reaction. So this is your equation for first order, and R value will be R naught by 2, right? R value will be R naught by 2 and this one will become 0.693 by K. T half will be 0.693 by K. Okay. Next, we have here what is the rate law or rate expression, and define the rate constant or velocity constant of a specific reaction rate. So rate law is what? Rate law is any expression, okay, which tells you the dependency of the rate on the concentration of the reactants raised to the power of a stoichiometric, raised to the power of some value. So you can see here rate law is the expression in which the reaction rate is given in terms of the molar concentration of the reactants, with each term raised to some power which may or may not be same as the stoichiometric coefficient of the reacting species in a balanced chemical equation. Next, what is the rate constant? Rate constant of a reaction is equal to the rate of the reaction when the molar concentration of each of the reactant is taken as unity. Okay, means rate is equal to K into, suppose, A to the power of n. Now when this A is taken as 1, then the rate is equal to rate constant. Next, define half-life, and how many times does the T of 0th order reaction increase if the initial concentration of the reactant is doubled. Okay, this is also very simple. Half-life, time taken to reduce half of its initial concentration. Then what is this one? By how many times does the 0th order reaction will increase? So if you just now we have solved that for 0th order reaction, T naught or T half is equal to A naught by 2K, right? So what will happen? In a 0th order reaction, if the initial concentration of the reactant is doubled, then T half will also double, right? So that is what we have here. Okay. Next is question number 20. What is the effect of temperature, and define the temperature coefficient of a reaction. So temperature is what? Whenever the temperature increases by 10 degree, the rate becomes double. And how do we represent temperature coefficient of a reaction? Is defined as the ratio of the rate constant of a reaction at a particular temperature to the rate constant at 10 degree lower temperature. Okay, that is, this is your temperature coefficient, Kt plus 10 by Kt, and which is always equal to or approximately equal to 2. Okay. Next, name the factors on which the rate of a reaction depends. I think this we have already discussed. Okay, no, solubility in that chapter we have discussed. Here, temperature, concentration, catalyst are the most important things. Other factors you can see here. Okay. Next, molecularity, elementary and order. All the definitions I am giving you because this can be asked in the 2-marker sections. So what is molecularity? Number of species reacting in an elementary reaction. Okay. And what is elementary reaction? Those reactions which takes place in one step. And what is order of a reaction? The sum of the powers of the concentration terms in the rate expression. Okay. So you can see, suppose this is there, A to the power of L, B to the power of M, then the order of the reaction is L plus M. Okay. Next, slowest step in the complex reaction is called as your rate determining step. Which step of the reaction decides the order of the reaction? Slowest step. For what type of reaction is molecularity and order are same? In the case of elementary reactions. Okay. Just a minute. Okay. Which is the slowest step? The rate determining step. Which is the rate determining step? The slowest step. Opposite type questions. Okay. Next, for what type of reactions the molecularity and order are same? Order and molecularity are same for the slowest step of a complex reaction. Clear? Next, we'll have the difference between order and molecularity. I have given you 6 points. You can just practice any 3. Okay, because in exam you will be asked to write 3 points maximum. So order is something which is sum of the powers, and it is the number of species reacting. So the first point is your definition. Then order is experimentally determined. Molecularity is theoretically determined. Order can be 0, negative, positive, fraction, anything. Molecularity is a, it can be only, it cannot be 0 or a fraction. Okay. So these are the points that you can write down. Next, what is activation energy? So this is what oxygen is available in air, yet fuels do not burn spontaneously at the room temperature. Why? What is threshold energy? So this is very important. See. Reactant molecules, okay, they have to gain a certain, so reactant molecules will have to reach up to threshold energy, after which they can convert to products. Okay, reactant molecules should have a minimum threshold energy, after which they can form the products. So these reactant molecules, to reach up to threshold energy, you have to provide some energy. Okay, suppose for a reaction, the reactant is at 5 joules, they need at least 10 joules, or you can say they need at least 15 joules. Okay, after which they can form the product. Now they are having 5 joules. This 15 joule is called as your threshold energy. For 5 joules to 15 joules, how much energy you have to provide? 10 joules. That is your activation energy. Okay. So what is the energy of activation? See, the minimum excess energy required by the reactants upon collision to form the activated complex is called as the energy of activation. Next, See, oxygen is available and the fuels are present. Why don't they catch fire? Because there is a minimum threshold energy that the fuels should have. They do not have this energy in the room temperature, so that is why they do not catch fire. So the activation energy for the combustion reaction of fuels is very high at room temperature, therefore they do not combust or they do not burn. Next, what is threshold energy? The minimum energy that the reactant molecules should possess in order to form products upon collision is called as your threshold energy. So you can see here, this is reactant energy, this is threshold energy. From reactant to threshold, if I want to reach, I have to provide activation energy. So these are minor definitions you should be knowing. This is important question. What does Arrhenius theory of activated complex tells you, and explain it with an example or by drawing the energy level. So Arrhenius theory says that reactants do not directly convert into products. They undergo or they form an activated complex. And now this activated complex is a very short-lived transition state, and this activated complex gets converted to product. Okay. So, according to Arrhenius theory, the reaction can take place only when the reactant and molecules collides to form an unstable activated complex. It exists for a very short time and then breaks to give you products. So, if you have H2 and I2 reactants, okay, then what will happen? This H2 and I2 will form an intermediate complex, HI, one intermediate activated complex is formed. Now, this one will break to give you HI. Okay. So, you can see here H2 plus I2 is there, then one activated complex is formed, and then threshold energy is there, and that one will give you 2HI. Clear? Okay. Next we'll go to electrochemistry chapter. What are electrochemical cells? Mention the type of electrochemical cell, very basic question. So electrochemical cells are those cells where either electrical energy is converted to chemical energy or chemical energy is converted to electrical energy. From the name itself you can write down this answer. What are the type of electrochemical cells? You have galvanic cell and electrolytic cell. So in galvanic cell what happens? Chemical energy is converted to electrical energy. In electrolytic cell, electrical energy is converted to chemical energy. Okay. Next, how do you represent a Daniell cell symbolically and write the reactions, electrode reactions of the cell reaction? So Daniell cell is your zinc copper cell. So it is represent like this: Zn solid, then this one Zn2 plus, aqueous, this is there, then copper 2 plus aqueous plus copper solid. Not plus, you have to mention like this. So now what is the anode reaction? Zn will give you Zn2 plus 2 electrons, and cathode will give you Cu2 plus 2 electrons, that is copper. Next, what are the functions of salt bridge? Very important question. So it provides the electrical contact between the two solutions, and thereby it completes the circuit. The first thing is it completes the circuit, prevents the mixing of the two solutions. Third is maintains electrical neutrality in both the solutions by the transfer of ions. If this electrical neutrality is not maintained, then the flow of current will stop. So first of all, completes the circuit, prevents the mixing of two solutions, and maintains electrical neutrality. Next, what we have, what is electrode potential? Write the relation between the E0 of the cell and the equilibrium constant of the cell reaction. Write down the Nernst equation for electrode potential. Okay. So yes, what is electrode potential? First of all, electrode potential is the potential difference between the electrode and its electrolyte. Okay. So the potential developed between a metal rod and its own ions in a solution at equilibrium is called as electrode potential or single electrode potential. It is denoted by E and expressed in volts. It is denoted by E and expressed in volts. Okay. Next, write the relation between E0 of the cell and equilibrium constant of the cell reaction. So it is your E0, okay, E0 of the cell and equilibrium constant, right? So you can write 2.303 RT by NF into log of K. Okay, that is the relation. This is your answer number B. Next, write down the Nernst equation for the electrode potential. So when you want to calculate only for electrode potential, it is like this: Mn plus n electrons gives you M. Okay, so I will have E of Mn plus 2m is equal to E naught of Mn plus 2m minus 0.059 by n log of 1 by Mn plus. Okay. Next, this is important slide. So there are different things. The question can be, write down the factors on which the electrode potential depends, factors on which the metallic conductance will depend, ionic conductance will depend, factors on which the conductivity will depend, and the factors on which the products of electrolysis will depend. So I have made a list of all the factors. You can go through them. Okay, so the first one is the factors on which the electrode potential or the EMF. Okay, on which either of them have the same answer. This you can directly generate from the Nernst equation. You have concentration of the ions, you have temperature, and you can write down the nature of the electrode material. Okay, that is what the EMF of the cell will also depend, and the electrode potential will also depend. The next one is your metallic conductance. Metallic conductance again depends on the nature and the structure of the metal, depends on the temperature, and depends on the number of valence electrons per atom. Next, coming to ionic conductance, that is your electrolytic conductance, depends on the nature of the electrolyte, whether it is a strong or a weak electrolyte. Temperature, it increases with the temperature. Nature of the solvent and its viscosity, nature of the ions in the solution, size of the ions and their solvation effect. Next, coming to conductivity, that is kappa value. Kappa value also depends on the nature of the electrolyte, depends on temperature, depends on pressure. Next, products of electrolysis depends on type of electrolyte, type of the electrode used, depends on standard electrode potential of the competing ions, then depends on the concentration, and also depends on over voltage. Okay. Next, we have what is specific conductance or conductivity, SI unit of molar conductance, specific resistance, and cell constant. So see, specific conduct, it is the conductance of the electrolytic solution placed between two electrodes of length 1 meter apart and area of cross section 1 meter square. So when you have taken a cell and you have placed two electrodes, they are 1 meter apart and their area of cross section is 1 meter square. At that time, that volume of electrolyte can conduct how much electricity, that is called as your conductivity. Okay. Next, write down the units. So SI unit of molar conductance is S centimeter square mole inverse. Okay. Specific resistance is S centimeter inverse. Specific resistance, sorry, one second. Specific resistance is your rho value, right? R is equal to rho into L by A. So rho value is equal to R into A by L. So it is ohm centimeter. Okay. So it is your ohm centimeter. Next, cell constant L by A is your centimeter inverse. Okay. Next, we have what is the molar conductance or molar conductivity, how is it related to the concentration, mention its unit. So molar conductance is what? See, it is the conductance of all the ions produced in the entire solution which contains 1 mole of an electrolyte. So if there is an electrolyte which contains 1 mole, and from all the ions of that 1 mole of electrolyte, how much electricity can be conducted, that is your molar conductance, right? Next, what is it is related to concentration. How is it related to concentration and conductivity? So I have to just write down the formula for this one. Molar conductivity is equal to kappa into 1000 by C. Okay. Next, mention its unit. So it is S centimeter square mole inverse. Okay. Question number 8, write the d by Onsager equation and mention the various terms. So lambda is equal to lambda naught minus a root over of c, where lambda is the molar conductivity, lambda naught m is the limiting molar conductivity or conductivity at infinite dilution, a is your constant and c is the concentration of the electrolyte. Okay. So let's see the next question. What is the effect of dilution on conductivity and molar conductivity? So conductivity will increase, molar conductivity will increase and conductivity will decrease. Okay. So that you can see here, explanation is there. Three differences between metallic and electrolytic conductors. You can write any 3 points here. So for example, here it is due to movement of electrons and here this is movement of ions. Next you have here solid state, they conduct in the solution state. Metals do not decompose, electrolytes decompose. So there are examples, so many points are there, you can just collect any 3. Next, how much charge is required for the following reductions to happen? So Al 3 plus 2 Al, we need 3 Faraday, right? So 3 Faraday means 3 into 96500 coulombs. Okay. Next we have Cu2 plus 2 Cu. You can see plus 2 charge is there, right? So you need 2 more electrons to make it 2 like plus 2 neutral. So 2 Faraday means 2 into 96500 coulombs. Next, third one is MnO4 minus 2 Mn2 plus. So here the oxidation state of manganese is plus 7 and here it is plus 2. Plus 7 to plus 2 is how many electrons? 5 Faraday. So it is 5 into 96500 coulombs. Okay. So just calculate this one and you will get the answer. Next, SHE, very important question. Reactions and the symbolic notation and why platinized platinum is used for the construction of SHE. Very important question, please do this properly. Okay. So first of all, if you see the diagram should be done properly here. You have a glass tube, you have a glass rod here and you have a platinized platinum connected with platinum wire, then is a mercury, then we have a copper wire. So please do the proper leveling, see this diagram again and again and practice it. Next, coming to the standard hydrogen electrode consists of a platinum foil, okay, platinum foil coated with finely divided platinum. The platinum foil is connected to a platinum wire with mercury. Okay, you can see the platinum, this small part is your platinum wire through a mercury. Next, what happens? Copper wire is connected from the mercury for external circuit. Okay, the platinum foil is dipped in 1 molar HCl solution as shown in the figure. Please, very important question, do this question properly. Next, what we have, the reactions H plus plus 1 electron gives you half H2, and how will you represent it symbolically? Platinum solid. Okay, then you have hydrogen gas, then you have H plus 1 molar solution. Next, what we have, that why do we use platinized platinum? To increase the surface area so that more amount of hydrogen gas can be adsorbed on it. Okay, next we have give reasons. Zinc displaces copper from copper sulfate solution because zinc is more reactive. Iron displaces copper from copper sulfate solution because iron is more reactive than copper. Zinc displaces hydrogen but copper does not, that is because here you can explain like this. So first one, zinc is more reactive than copper. The second one is important here. So zinc being more electropositive and being above hydrogen in the activity series displaces the hydrogen from the dilute sulfuric acid, but copper is below hydrogen in the electrochemical series, hence cannot displace hydrogen from the sulfuric acid. Now next one, by this one, iron displaces copper from copper sulfate because iron is more reactive than copper. Okay. Next, this H2O2 fuel cell diagram, very important, please practice it, and the cathode and anode reaction is very important. So please write down this reaction again and again, practice it, a question will definitely be asked from here. Next, explain the rusting of iron as an electrochemical phenomena. This is also important question. Okay, so what happens exactly here? See, any spot on the metallic or the iron rod can behave as an anode, and iron will undergo oxidation there to give you Fe, gives you Fe2 plus 4 electron. Now these 4 electrons will move to the different location on the rod, okay, and then it will reduce the oxygen present in the atmosphere in the presence of H plus ions. So what will happen? Oxygen, these electrons in the presence of H plus ions get reduced to give you water. Now the ferrous ions are further oxidized. So you see this ferrous ions, these are further oxidized by atmospheric oxygen to ferric ions, okay, which come out as rust in the form of hydrated ferric oxide. Clear? This is important question. You can write down in these 3 points. Next, lead storage battery cathode anode reaction. Just you have to remember what is the reaction of Pb. So at anode, Pb gets oxidized to Pb plus 2. At cathode, Pb plus 4 gets reduced to Pb. Okay. Next we have Kohlrausch law and 2 applications of Kohlrausch law. So it states that, see, Kohlrausch law states that the molar conductance of an electrolyte at infinite dilution is equal to the sum of the ionic conductances of the respective cations and anions of the electrolyte. Okay. Next, it is used to determine the molar conductivity of a weak electrolyte, which cannot be determined, and it is also used to determine the extent of dissociation. Okay, these are the 2 applications. Kohlrausch law definition is again very important question. Next, Faraday's first law and second law. The statement I'm not going to explain you this one, direct statement based question. Faraday's law, its formula, then you have Faraday's second law. And what is the Faraday's second law formula? M1 by M2 is equal to E1 by E2, right? E1 and E2 are the equivalent weights of the metals. Okay. Next, this is important question. Okay, direct measurement of the conductivity of ionic solution by Wheatstone bridge is not possible. Give reasons and suggest a remedy to resolve it. So first of all, the first problem is electrolytic solutions are liquid, right? How can you conduct a wires to a liquid solution? That is the first thing. Second thing is, when we use direct current, the composition of the electrolyte is altered. So the solutions for that is use alternating current, and to measure the conductance of an electrolyte, we use conductivity cells. Okay, inside the conductivity cell we take the electrolyte and we connect the wires to the conductivity cell, not to the electrolyte. So that is how you can solve this problem. So you can see here that first is direct current will alter the composition. Next, solutions cannot be connected to the bridge, to the Wheatstone bridge like solid conductors. So the solution is, instead of direct current, use alternating current, and electrolytic solutions is connected to the Wheatstone bridge by using a conductivity cell. Okay. Next is anode and cathode reactions of a dry cell. You can write down here what is the role of the ammonia produced. The role of the ammonia produced is it forms complex with the Zn2 plus ions. Okay, to give you ZnNH3 whole 4 2 plus. Next, next anode and cathode reaction. So which is your anode? Zinc is your anode. Cathode is which one? Graphite rod surrounded by MnO2. And then what is the electrolyte used here? NH4Cl and ZnCl2. What is the voltage produced here? 1.5 volt. Okay. Next, plot the graph of molar conductivity versus concentration for strong and weak electrolytes in the solution. So you have already seen this graph. So here we have molar conductivity and here we have concentration. So the graph is like this. This is for strong electrolytes. I'm just writing like this, and this is for weak electrolytes. Okay, that's the first thing. For strong electrolytes, write the equation that represent the variation of molar conductivity with dilution. So it is your D by Huckel-Onsager equation. So I have written these values here. Lambda m is molar conductivity. Lambda m is molar conductivity. Okay, then lambda naught m is your limiting molar conductivity. Limiting molar conductivity. Okay, then A is your constant. Okay, and root over of C is concentration. Clear? Next, we have explained the determination of standard reduction potential of zinc by using SHE. This is a very simple question. Just what you have to do, first thing is you have to consider SHE as a reference electrode. Step number 2, you have to couple it with the zinc rod. Then the potential difference of zinc and SHE is measured using a potentiometer, which will give you a value of minus 0.76 volt. Okay. Next, we'll go to DNF block chapter. Questions here I have taken. Okay, so first of all, name the 3D series elements having maximum melting point and minimum melting point. Okay, so maximum melting point is your chromium in the 3D series itself. Okay, if you see the complete D block, then it is tungsten, but in 3D series it is chromium, and minimum melting point is your zinc. Okay, next, Vanadium pentoxide is amphoteric oxide. Explain. Give an example of amphoteric oxide. Okay, sorry. So vanadium B2O5 reacts with both acids and bases. So that is why it is an amphoteric oxide. So it reacts with acid to give you VO4 3 minus and VO4 plus respectively. So sorry. With alkalis it gives you VO4 3 minus, and with acids it gives you VO4 plus. Okay, and hence vanadium pentoxide is an amphoteric oxide. Some other example of amphoteric oxide is Cr2O3. Next we have why tungsten metal is used in bulbs but not to infuse the wires. So tungsten is a very high melting point, so it is used in bulbs. It cannot be used in fuse wires because in fuse wires the material must have a low melting point. Okay, the fuse wires means should be something which should immediately break the circuit. Okay, when there is some problem is happening, when some accident is happening, the fuse wire should be something which should immediately melt and the circuit should be broken and the flow of electricity has to be stopped there. But if the fuse wire is made up of a metal which is very high melting point, then even though some accident is happening, that will not melt. If that will not melt, the circuit will be there and the electricity will be flowing and we cannot stop the accident. Okay, so that is the difference. Next, why manganese exhibit oxidation state of +7 only with oxide. So in case of oxygen, what happens? It can form a double bond, right? So that is why it can oxidize or it can have a higher oxidation state. So in the case of oxygen, manganese shows the highest oxidation state of +7. This is because manganese forms p pi d pi multiple bonds using the 2p orbitals of oxygen and the 3d orbitals of manganese. So there is a p pi d pi bond formed between the 2p orbitals of oxygen and 3d orbitals of manganese. With fluorine, manganese display an oxidation state of +4 because of the single bond formed between or caused by the unavailability of 2p orbitals in F for multiple bonding. Okay, so in case of fluorine, what happens? You can form only single bond, whereas in oxygen you can form double bonds. Okay, so that is the reason here. Next, give reason Cu2 plus is more stable than Cu plus. Yes, why? Because of higher negative hydration enthalpy. Ionization enthalpy increases along the transition elements from right to left. Yes, along right to left, along left to right, the effective nuclear charge increases. So that is why the size will decrease. Okay, so yes, so that is because of high negative hydration enthalpy. Next, ionization enthalpy increases along the transition elements from left to right due to the increase in nuclear charge as the electron fill the inner orbitals. Okay, so this is basic question. Again, I am not going to a very detailed explanation because at this point of time you should just learn these questions, revise these questions, understand these questions and write them. Next question, why do transition elements have higher enthalpy of atomization? Enthalpy of atomization is maximum in the middle of each elements. Then in the series scandium to zinc, the enthalpy of atomization of zinc is the lowest. Enthalpy of atomization is more in 4D and 5D as compared to 3D. Give reason. Okay. So I have covered all the questions related to enthalpy of atomization here. So first of all, what happens? Enthalpy of atomization is higher in transition electrons, and these unpaired electrons can be involved in intermetallic bonding. Okay, so when metallic bonding is there, the intermolecular forces increases and it becomes very difficult to separate the atoms. So that is why the enthalpy of atomization is very high. So you can see because of large number of unpaired electrons in the atoms, they have stronger interatomic interaction and hence stronger bonding between the atoms. Clear? Next, why the enthalpy of atomization is maximum in the middle of each series? So in the middle of each series, the number of electrons, the number of unpaired electrons is more. So more number of unpaired electrons means more stronger bonding. More stronger bonding means what we will get? See, due to the more number of unpaired electrons in the middle of each series, interatomic interaction is stronger. Okay, therefore enthalpy of atomization is maximum in the middle of each transition series. Next we have scandium to zinc. The enthalpy of atomization is zinc is the lowest. Why? So zinc has completely filled d orbitals. It does not have any unpaired electron. If there is no unpaired electron in zinc, then there will be no metallic bonding. If no metallic bonding, then there is no I can say the intermolecular forces is very weak, and that is why zinc can melt easily. Okay. So the extent of metallic bonding of an element is proportional to the enthalpy of atomization. Due to the absence of these unpaired electrons in zinc, the interatomic electronic bonding is the weakest, and that is why they have the least enthalpy of atomization. Next, enthalpy of atomization is more in 4D and 5D. That is because strong metal-metal bonding is in heavy transition metals. Okay. So as the mass increases, the intermolecular forces also increases. Okay. So that is why the enthalpy of atomization is high. Next, Cr2 plus is reducing, whereas Mn3 plus is oxidizing when both have D4 configuration. This I will explain first, then I will show you how to write the answer. So if you see Cr2 plus, okay, it is D4 configuration. It is if it is getting converted to Cr3 plus, it will have D3 configuration and a stable T2G3 configuration. Okay. So now you see this T2G3 configuration is having lower energy and is exactly half filled. So that is why it is more stable in Cr3 plus. So what will happen? It will undergo oxidation. When it is undergoing oxidation, it will behave as a reducing agent. Now if you talk about manganese, Mn plus 3 to Mn plus 2. Mn plus 3 is D4 configuration, Mn2 plus is D5 configuration. So from plus 3 to plus 5 we are getting a stable configuration here of D5, exactly half filled configuration. So from plus 3 to plus 2, when I am getting exactly half filled configuration, I can say that it is undergoing reduction, so it will behave as an oxidizing agent. Okay. So here you can write down Cr2 plus is reducing because its configuration changes from D4 to D3, and the latter has the exactly half filled T2G configuration. Similarly, Mn3 plus is oxidizing because the configuration changes from plus 3 to plus 2 results in a stable half filled D5 configuration. Okay. Next, which is stronger reducing agent, Cr2 plus or Fe2 plus, and why? So if you see stronger reducing agent means it will reduce others, itself it will get oxidized. So Cr3 plus, okay, it is having your D3 configuration T2G, and Fe2 plus, it will undergo oxidation means Fe3 plus, that is D5 configuration, exactly half filled. Now out of these two, which is more stable? If you have remembered the splitting of d orbitals, the T2G level goes to the lower energy side. So lower energy means more stable, so obviously this is more stable, so that is why this is a stronger reducing agent. Okay. So you can see here Cr2 plus is a stronger reducing agent than Fe2 plus. This is because the configuration of Cr2 plus changes from D4 to D3, and D3 is stable due to half filled T2G level. Okay. Next, catalytic property of transition metals. What are the reason for that? It is having variable oxidation state, large surface area, presence of incompletely filled d orbitals, formation of intermediate complexes, and one example also you can give here. One or two examples can also be given. So this is very important question. So please prepare at least any 3 properties out of this 4. Variable oxidation state, incompletely filled d orbitals, ability to form intermediate compounds. Okay, these are the what I feel more probable answers. Let's see the next question here. What is lanthanide contraction, cause of lanthanide contraction, and 2 consequences? So the steady decrease in the size of the elements along the period is called as your lanthanide contraction. What is the cause of that? Poor shielding effect of 4f electrons. And what are the consequences? We have the size of 4d and 5d elements are almost similar, so they have same physical properties, and it becomes difficult to separate them. And the second consequence is along the period what happens? The basicity decreases. Okay, so you can see here, due to the poor shielding of 4f orbitals, here the definition and consequences due to lanthanide contraction, the atomic radius of Zr and Hf is almost same, so they occur together, hence it is difficult to separate them, and basicity will decrease from lanthanum to lutetium. Next, study of actinoids is very difficult. Give 3 reasons. They are radioactive, they have very short period, or they have half-life period is very short, and they are produced in nanograms. Okay. Next, potassium dichromate manufacture. So please remember this reaction. You should do balancing of equation. Okay, balancing is important. Many students have the doubt that inorganic chemistry reactions should be balanced. For organic chemistry not required, but for this one it is required. So please note down, practice it again 5 to 10 times. Next we have KMnO4 preparation method. Again 2 steps are there. Please practice it again. I am not explaining anything here. Going to the next question. Why CE shows +4 oxidation state? What is the highest oxidation state shown by the actinoids, or name an element that shows the highest oxidation state among the actinoids? So CE shows +4 oxidation state because Ce +4 has a stable configuration of noble gas Xe4F0. The oxidation state shown here is +7, and which element shows this oxidation state? Np and Pu, okay, neptunium and plutonium. Next I will see lanthanides and actinoids difference. You can write down any 3 points. Electrons enters into 4f orbitals, electrons enters into 5f orbitals. Non-radioactive, radioactive. Being binding energies are higher, binding, so if you don't want to write this point, that is also fine because we have not explained this one. So this is not required, I am cutting. Less basic, more basic. Maximum oxidation state is +4, there it is +7. Greater shielding effect, they have poor shielding effect. Lanthanide contraction is lesser, actinide contraction is more. Any 3 points you can write down. Next, composition of mic metal and its use. This is also important question. Okay. Okay, so lanthanide 95%, iron 5%, and traces of sulfur, carbon, calcium and aluminium are called as your mic metal, and it is used in magnesium based alloys to produce bullets, shell and lighter flint. Okay, these are direct theory based questions, so we'll move to the next question. Yes, so these are very important question. I will do any one of this and I'll tell you how to solve this question. Okay, so for example, you have to calculate the magnetic moment of a divalent ion in aqueous solution whose atomic number is 25. Okay, so 25 atomic number means I can know that it is manganese, right? So Mn configuration is what? 3d5 4s2. Divalent means Mn2 plus, so that is your 3d5 configuration. So I will have like this. Okay, 1 2 3 4 and 5. Now 3d5, what is the magnetic moment? Root over of 5 into 5 plus 2. Okay, so that is root over of 35. I think it will come some 5.9. Yes, so if you solve this, you will be getting 5.9 Bohr magneton. Okay, so that is what you can do for any question. So for this, you must remember the electronic configuration of scandium to zinc. Without remembering that, you cannot solve this question. Okay, next 17th one. On what ground can you say that scandium is a transition element but zinc is not? Next, silver atom has completely filled d orbitals in the ground state. How can you say that it is a transition element? Okay, so the basic rule for transition element is that it should have unpaired or partially filled d orbitals either in the common oxidation state or in the ground state, right? So scandium in its scandium, when it is there on the ground state, it has incompletely or partially filled d orbitals, whereas zinc is not having. So that is why we can say that scandium is a transition element but zinc is not. Similarly, silver, what happens? In its ground state, it doesn't have any partially filled d orbital, but in the common oxidation state, that is in Ag2 plus, it has incompletely filled d orbital. So that is why that is considered as a transition element. So how can we write this answer? So scandium contains partially filled d orbitals, that is 3d1, so it is considered as a transition element. Zinc contains completely filled d orbitals in its ground state as well as in its oxidation state, so that is why it is not considered a transition element. For second one, silver can exhibit +2 oxidation state in which it has incompletely filled d orbital, hence it is a transition element. Next, structure of chromate and dichromate ions. So I can write like this. Chromate is CrO4 2 minus, right? So it is like this. Okay, chromate, and dichromate is Cr2O7 2 minus. So you have like this. Okay, clear? So this is your dichromate and this is chromate, both are tetrahedral structure. Similarly, E naught of M2 plus 2M value is positive, give reason for this. This is also very important question. Okay, See, so first of all, the E naught value depends on three factors, okay. So the E naught value first of all depends on your atomic enthalpy, ionization enthalpy and hydration enthalpy. So you see that the atomic enthalpy is positive when you, because you have to provide energy. The ionization enthalpy is very high for copper. Why? Because you are removing the electrons from the Cu2 plus, right? So first of all, you remove one electron, you get Cu plus, which is having 3d10 configuration, and when you remove the second electron, you have to provide very high energy. Then the hydration enthalpy is a negative term. Now copper has high atomic enthalpy, this is very high, this atomic enthalpy, and this one is very low, low hydration enthalpy. So hence the value of E naught copper is positive, and high energy of transformation of Cu to Cu2 plus is not balanced by its hydration enthalpy. So the energy that is required here is very high. Okay, so that is why the overall number, when you add this plus this minus this, overall it comes out to be positive value. Okay, let us see the next question. Here you just have to name the elements. So the first question here is the element of the first transition series which has the second ionization enthalpy, so that is nothing but copper. Next we have element of the first transition series which shows the highest number of oxidation states, that is your manganese, and element of the first transition series which has the lowest enthalpy of atomization, that is your zinc. Okay. Next we will see, explain the color of the transition metals. Zn2 plus salts are colorless, copper 2 plus salts are colored, give reason. Very simple answer. So first of all, for color we need unpaired electrons. Whenever there is unpaired electrons, the electrons can undergo transition. Which type of transition? DD transition. So during this DD transition, it occurs in the visible region and we see the color of the compound. So I can explain it in this way. The color of the transition metal is due to the presence of unpaired electrons in the d orbital which undergo DD transition. Now the unpaired d electrons absorbs the color from the visible region and undergo DD transition and radiate the complementary color. Now why Zn2 plus salts are colorless? That is because of absence of unpaired electrons. Why copper 2 plus are colored? Because they have unpaired electrons. So whenever a question comes why something is colorless or white, the reason is it does not have unpaired electrons. And whenever a question comes why something is colored, that is because of the presence of unpaired electron which can undergo DD transition. Okay. Next, write the balanced chemical equation for the following reactions. Okay, so first one is reaction between potassium permanganate and iodide in the acidic medium. Okay, so in acidic medium what happens? MnO4 minus gets converted to Mn2 plus, I minus gets converted to I2, rest you have to balance it. So next one is your so I'll just tell you how can you balance if you do not remember this one. Okay, so just I'll give you one example. So I have MnO4 minus and I have I minus. Okay, so just a minute. So I will write acidic medium, right? So MnO4 minus will get converted to Mn2 plus. This much you should be knowing because in acidic medium it happens +7 to +2. So for this I need 5 electrons, reduction of 5 electrons is there. Then I have 4 water, so I will add 4 water here. So to balance oxygen you should add water. So then we have 8H plus, but this side there is no hydrogen, so I will add 8H plus. You have studied in redox reaction how to balance this type of reactions. Now if I compare the I minus, 2I minus will give you I2 plus 2 electrons, right? To make the number of electrons same, this one should be multiplied with 2 and this one should be multiplied with 5. So I will get 16H plus 2 MnO4 minus, right? Then 10 electrons, that will give me 2 Mn2 plus 8 water. Okay, now here it is 10 I minus gives 5 I2 plus 10 electrons. Okay, so now you can add these 2 electrons. So what I will get here, this 10 electrons and then 10 electrons will get cancelled. I can write 16H plus 2 MnO4 minus plus 2I minus, okay, will give me 16H plus 2 MnO4 minus, then I have, sorry, not 2I minus, 10I minus, will give me 2 Mn2 plus, okay, plus 8 water, okay, then I have 5 I2, So this is what the balanced equation I got, and I think that is what also I have written here, right? So like this you can write down. The next thing here is in the neutral medium. This is important. So in neutral medium, MnO4 minus gets converted to MnO2 and I minus gets converted to IO3 minus. Next we have potassium permanganate and oxalate ion. So oxalate ion gets converted to CO2 and MnO4 minus gets converted to Mn2 plus because it is acidic medium. I told you how to balance. Following that same mechanism you can balance the reactions. Next, interstitial compounds. So what is interstitial compounds? The compounds in which there are small voids or small you can say vacuum spaces, and that vacuum spaces are occupied by other small atoms like your nitrogen, hydrogen, carbon. Okay, these are trapped in the empty spaces of the transition elements, and these are called as your interstitial compounds. Now what is the benefit of that? We see that their physical and chemical properties, like they have high melting point, they are chemically inert, and they retain the metallic conductivity. They increase the hardness of the metals. Okay. Next, composition of the following. So this is something fact based question. This question was there in the I can say question bank. So please have a look at this. UK copper 99% pure copper with small amount of sulfur, iron and oxygen. Silver UK coins 75% copper and 25% nickel. Ziegler-Nattler catalyst, you have titanium compounds and organoaluminium compounds such as AlC2H5 whole 3. Okay. Similarly, next, what are the catalysts used in different process? Haber's process is iron, Walker's process is palladium, hydrogenation of fats is nickel. This is used, this is given in the applications of your DNF block compounds. So please read that applications properly, you will get these things there. Next, give reasons. Actinoids have higher oxidation states. Actinoid contraction is greater than lanthanide contraction. So actinoids can have higher oxidation state because the energy gap between 5F, 6D and 7S is very less. If the energy gap is less, then the electrons can participate better in the reactions. So that is why this is, we can find more number of oxidation states in actinoids. Next, the actinoids exhibit a greater contraction in the size from element to element compared to the lanthanide due to the increased nuclear charge without a corresponding increase in the shielding effect. So actinoids have because of their more number of protons, the effective nuclear charge has increased, and at the same time the shielding effect has decreased, right? So that is why it overall contributes to a greater contraction, or that is why actinoid contraction is much higher. Okay, so next we have transition elements forms a large number of complex compounds. So what are the reason for that? Any three? Please remember, this is very important question. Okay, complex compounds because smaller size, large ionic charge and availability of d orbitals. Okay. Next we'll go to coordination chapter, Werner's theory and its postulate. Very important question, please remember this one. So Werner's theory, primary valency and secondary valency. Primary valency will give you the, or it is satisfied by your generally neutral atoms or negative ions, right? Whereas secondary valency is primary valencies are normally ionizable and are satisfied by negative ions, whereas secondary valency is your non-ionizable and are generally satisfied by neutral and negative ions, right? And secondary valency will also tell you about the geometry of the metal. It is equal to the coordination number and gives you the geometry of the complex. Okay, so this you already know, means I think you can read from here. Next, some applications of coordination compounds. That this can be a direct question or it can be asked in your MCQs or in a 2-marker, just like this, that where hardness of water, which complex is used, EDTA is used. In the extraction process, gold is used. Purification process, nickel carbonyl is used. Chloroform has which metal? Magnesium. Hemoglobin has iron, and vitamin B12 has cobalt. So these are some important things that you should be knowing. Next, draw the geometrical isomers. So this, remember, this example is very important. Okay, it exhibits facial and meridional isomers. Okay, so for example, CO, you have like this, right? So if you have like this NH3, NH3 and NH3, and you have NO2, NO2 and NO2. Okay, so this is what facial geometry. Okay, And then you have meridonial. Meridonial means I have CO. Okay, so if you have NH3, okay, and I put like this, just a minute, yes, NH3 and NH3, and here NO2, NO2 and NO2. Okay, so this is facial and this is meridonial. Along the meridian you should have one isomer, one ligand. Then PT NH3 hold to Cl2, this you can easily draw cis and trans. So PT, if you have like NH3, I'm just writing the first letter, write down the full name, NH3, NH3 on the same side, so this is trans. And then you have PT, you have on opposite side NH3 Cl, sorry, yes, this side you have NH3 Cl and Cl, so this is your trans. Okay, next definition, ambidentate, heteroleptic and chelating ligands. So ambidentate ligands means those ligands which have two donor sites, right, and but either of them will bind to the metal at one time. So example, NO2 minus and CN minus. Heteroleptic means more than one type of ligand will be present in the complex. Then chelating ligand is when a di or a polydentate ligand uses its two or more donor atoms simultaneously to bind to a single metal. It is called as a chelating ligand. Okay, they form generally cyclic complexes and they are very much stable. Next, synergic bond in metal carbonyls. So this is very important. So metal carbonyls have both sigma bond and pi bond. Okay, very, very important. Listen carefully. Metals and carbonyls. Generally, metals and ligands have only sigma bond. But in case of carbonyl ligands, there is sigma bond as well as pi bond. Now the sigma bond is formed due to the electrons donated by the carbonyl to the metal, right? So the I can say carbonyl donates its electron to the empty orbitals of the metal, empty d orbitals of the metal for the sigma bond formation, right? But when the pi bond is formed, at that time metal donates electrons to the carbonyl. Okay, so you can see here that the MC sigma bond is formed by the donation of lone pair of electrons of the carbonyl carbon into the empty d orbitals of the metal. When the pi bond is formed by the donation of a pair of electrons from the filled d orbitals of the metal into the vacant anti-bonding orbital of carbon monoxide. Okay, you can see the structure here. This is also important question. Next, limitation of CFT and limitations of VVT, 2 points or 2-3 points you should remember. VVT has many limitations, like it cannot explain the magnetic property, it cannot explain the color of the compounds, it cannot explain the, it has a lot of assumptions. So any 3 points you can take from here. Okay, and in case of CFT, the first thing is ligands are considered as point charges here, whereas they are actually not point charges, and it does not take into account the covalent character of bonding between ligands and metals. So according to CFT, the ligand and metal bond is completely ionic, right? It doesn't take care of the covalent bonding, doesn't give any importance to covalent bonding. So that are the limitations. Next, d orbital splitting in octahedral complex, very important. So please do the proper leveling here, draw the diagram, practice the diagram again and again. Please see what all levelings are there. If you do not write these levelings, you will not get the marks. So first there is d orbitals, then they go higher, and then there is splitting 2/5 and 3/5. This is not required to draw, but this all diagram and this bottom levelings many students do not do. Please do not do this mistake, write the complete thing. Similarly, we have for tetrahedral complex the same thing. Here also you should mention the levelings properly. Okay, not explaining this one. Next you have geometrical and optical isomers. Okay, so first of all you have this one, COCl2 En2, right? So I have COCl2 En2. So I can draw like this, CO En. Okay, so this is the trans form. Okay, now cis form will be, you can draw like this. Oh, this is again trans I am doing, sorry. So here this is the cis form, and here I have, can draw like this, mirror image of this one. So I'll get Cl, Cl, here it is En, and here it is En. Right. So this is the trans form, a cis form and its isomer, and this is the trans form. Next you have CO NH3 Cl En whole 2. So here also I can draw CO En2 is there, right, and you have NH3 and Cl. So this is the trans form. For cis form, what I can do, just take like this, En, then you have En, then you have NH3, and then you have Cl. Now you can draw the mirror image of this one, that is CO En, En, NH3 and Cl. Okay, so that is your cis form. Right. Similarly, CO NH3 whole 2 Cl2 En, you can draw this one in any form. So you have CO, okay, you have NH3 whole 2, NH3 whole 2, then you have Cl2, and then you have En. Okay, this is the other form, and you can draw the cis and trans form as well. So this is what I can say here, NH3 is on the same side, Cl is on the same side. So this is cis form. So if I draw another like this, where I take Cl on the transition, and here I take NH3, here I take NH3, and I take En, right. So Cl is opposite here, so I can put trans. Similarly, you can take NH3 on this one, that will also be trans, so you will get multiple isomers here. Okay. Next, geometrical isomers of this one, and how many of them will exhibit optical isomerism. Okay. So if you see here, I can consider that bromine and chlorine are one type of ligand, right? So they will have like I can consider them as one because both of them are halogen. So I will do first one thing, I'll fix bromine here and I'll put chlorine here, and I have here NH3 and pyridine. This is one thing. Next I will do here, bromine I will take, and this side I'll put now NH3 opposite to bromine, chlorine on the same side, and pyridine. Next I will have platinum, again bromine, I'll put pyridine on one side, then you have chlorine and you have NH3, right? So these all so this is basically the trans one, this is cis because bromine and chlorine are on the same side. Okay, now all of them will have optical isomers, all of them will exit. So total, write all the geometrical isomers and how many of this will exhibit optical isomerism, all of them. Okay. Next, NiCl4 2- is paramagnetic while NiCO4 is diamagnetic, though both are tetrahedral. Why? So very simple, in NiCl4 if it is paramagnetic means it has unpaired electrons, NiCl4 is diamagnetic because it has no unpaired electron. So how can you write this? So NiCl4 2- has sp3 hybridization and 2 unpaired electrons. So that is why it is paramagnetic. NiCO4 has sp3 hybridization and no unpaired electrons. So that is why it is diamagnetic. Okay. Next, we have some isomerism here, ionization isomerism, linkage isomerism. So definition and examples you should remember. Okay. So definition, example for these coordination isomerism and solvate isomerism. So not explaining these terms, these are very fact based questions. So just remember the examples and definitions. Next we have here, yes, electronic configuration and pairing energy. This is very important, very important. Please understand. First of all, if this one delta O is less than pairing energy, in that case what will happen? No pairing. Okay. If delta O is greater than pairing, then what will happen? Pairing. Okay, pairing of what? Pairing of electrons. So I'll just give you, for example, I have D4 configuration, okay, and I am giving you two cases where we have delta O is less than pairing energy and you have delta O is greater than pairing energy. Now delta O is less means the gap between T2G and EG is very less. If the gap is, it is like this. You see, if the gap is very less, then electrons can directly go to the higher level. So what will be the configuration here? T2G3 and EG1. Now if delta O is very high, than pairing energy. Okay, then 4 electrons will come here in the ground level only, and you will get T2G4. Okay, now we have D5 configuration. So for D5 configuration, you have delta O less than P and delta O greater than P. Okay, so if again it is less than P, I will get, there will be 1, 2, 3, 4 and 5. So I will have T2G3 and Eg2. And if it is higher, there will be pairing of electrons. So I will get T2G5. Okay, 1, 2, 3, 4, 5. That is what you should understand when there will be pairing, when there will be no pairing of electrons. Okay. Next, double salt and complex, difference between a double salt and a complex. So very important question. See, double salts can dissociate completely in water. So here we can example of different double salts. Also remember the name and the formula. So carnallite KCl.Mgcl2.6H2O, more salt FeSO4.NH4(2)SO4.6H2O, potash alum KAlSO4(2)12H2O. Now what is a complex? Complex will not dissociate completely in water. For example, FeCN6 4- or K4FeCN6. Okay. Next we have FeSO4 solution is mixed with NH4(2)SO4 solution in 1:1 molar ratio, but gives the test of Fe2 plus ions, but copper sulfate solution mixed with aqueous ammonia in 1:4 molar ratio does not give the test of copper 2 plus ions. Explain why. Very easy question. You have to think little bit. See, FeSO4 solution when mixed with ammonium sulfate solution in 1:1 molar ratio, it gives a test of Fe2 plus ions. So what happens exactly? They will form a double salt, right? So when a double salt is formed, Fe2 plus ions will be produced there when it will be dissolved in water. So they can, Fe2 plus ions is available, so it can give a test for Fe2 plus ions. Now if you take but copper SO4 solution mixed with aqueous ammonia, if you take copper and ammonia, then what will happen? They will form a complex, okay, in the ratio of 1:4. So copper ammonium complex will form. Now because complex has already formed, there is no free copper 2 plus ions, so that is why it will not show the test for copper. So you can see here that FeSO4 solution mixed with ammonium sulfate in 1:1 molar ratio forms a double salt, that is your more salt, FeSO4.NH4(2)SO4.6H2O, which ionizes in the solution to give you Fe2 plus ions, hence it gives the test of Fe2 plus ions. Now coming to copper sulfate solution mixed with ammonium sulfate solution in 1:1 molar ratio forms a complex, that is CuNH3(4)SO4. Now the complex ion here does not ionize to give you copper 2 plus ions, hence it does not gives the test for copper 2 plus ions. Okay. Next we have explain the hybridization and the magnetic property and geometry of CuNH3(6) 3+. This is a very important and an expected question, not only for copper NH3(6) 3+, it will be also asked for CoCl6 3+. Then you have for NiCl4 2+ and NiCN4 2-. Okay, so this question is very important. I'll just show you how to write one example. You have to do in the similar way for all of them. So first of all, you have to write cobalt 3+, right? What is its electronic configuration? 3d7, 3d6, right? Then I can write here that NH3 is a strong field ligand. NH3 is a strong field ligand, so pairing of electron takes place. Okay, so what will happen? So if I will also draw this one and show. Okay, 1 2 3 4 5 and 6, so 3d6, right? So when pairing of electrons takes place, 3d okay, 1 2 3 4. Okay, so 1 2, we have total 6 electrons, right? So when pairing of electrons takes place, this one will be there, 3d 4s and 4p. Okay, now 3d6, this will be giving you what hybridization? D2sp3 hybridization. Okay, D2sp3 hybridization. Now D2sp3 hybridization, what it will cause? You will get here NH3 ligands, right? So NH3 will be there. You have NH3, NH3. Okay, so this one will donate electrons like this. Okay, and that is why there will be a complex formed in this way. Now what is the hybridization? You can see the hybridization is D2sp3. Next we have magnetic property. Magnetic property, there is no unpaired electron, so it is diamagnetic. Okay, next we have geometry. So you can see coordination number 6 is there, so it will be what? It will give you octahedral. Okay, similarly you have to practice for other 3 compounds as well. Next, what is crystal field splitting and how does the magnitude of delta O decides the configuration of d orbitals in the coordination entity? So I have told you what is d orbital splitting. When there is a metal, all the d orbitals are degenerate, they have the same energy, but when the ligands approach, these d orbitals faces repulsion and they split, and that is only called as your crystal field splitting. So you can see when ligand approaches a transition metal ion, the d orbital splits into 2 sets, one with lower energy, the one with higher energy. The difference in the energy between the 2 sets of the orbitals is called as crystal field splitting energy and denoted by delta O for an octahedral field. Now how do we write the electronic configuration? So if there is delta O is less than P, then the 4th electron enters to the higher energy level, giving T2G3 Eg1 configuration, and if delta O is less than P, it becomes more energetically favored for the electrons to occupy the T2G orbital, and we get the configuration T2G4 Eg0. Okay. Next, CrNH3 whole 6 3 plus is paramagnetic while NiCN4 is diamagnetic. What is the reason? Just simply you can write here. Here there is D2sp3 hybridization, no unpaired electron, so it is diamagnetic. NiCN4 2 minus has dsp2 hybridization and no unpaired electron, so it is diamagnetic. Okay, 1 second. This is diamagnetic. Okay. Next, NiCl4 is paramagnetic while NiCO4 is diamagnetic, while both are tetrahedral. Simple, whenever magnetic thing comes, paramagnetic means it has unpaired electron. So you can write NiCl4 2 minus has 3 sp3 hybridization and 2 unpaired electrons. So that is why it is paramagnetic. While NiCO4 has sp3 hybridization, which is already given in the question, I think, no, okay, but it has no unpaired electron, so that is why it is diamagnetic. Okay. Next, FeH2O whole 6 3 plus is strongly paramagnetic, whereas FeCN6 3 minus is a weakly paramagnetic. Strongly paramagnetic means more number of unpaired electrons are present. Weakly paramagnetic means less number of unpaired electrons are present. So FeH2O has 3 unpaired electrons, so that is why it is strongly paramagnetic. It has only 1 unpaired electron, so it is a weakly paramagnetic. Okay. Next, solution of NiH2O whole 6 2 plus is green, but solution of NiCN24 is colorless. Why? Whenever color thing comes, so here we have unpaired electron, H2O is a weak field ligand. As a result, Ni2 plus has unpaired electron which has undergone DD transition. As a result, it appears green. Okay. Whereas NiCO4 is colorless due to the absence of an unpaired electron in the complex. CO is a strong field ligand that produces electron pairing. So here there is no unpaired electron. Sorry, 1 second. Okay, this was actually NiCO4. That's what I was thinking. Yes. So now see, NiCO4 is colorless. Why? Because there is no unpaired electron which can undergo DD transition. Clear? Next, FeCN6 4 minus and FeH2O whole 6 are of different colors in dilute solutions. Okay. So now if you see, See, the color of a particular coordination compounds depends on the magnitude of the crystal field splitting, which depends on the nature of the ligand. Okay. Now, CN is a strong field ligand, H2O is a weak field ligand. So, in the case of FeCN6 and FeH2O, the color differs because there is a difference in the CFSE. CN is a strong field ligand and having a higher CFSE value compared to CFSE value of the water, which is a weak field ligand. Now, this means that the absorption of energy for the inter-DD transition also differs, and hence the color is also different. So, in case of FeCN6, the splitting is high, so the energy that will be required for DD transition is different, whereas in FeH2O the splitting is low, so the energy that is required for transition is different, and that is why the color is also different. Next, explain the violet color of the complex TiH2O whole 6 3 plus on the basis of the crystal field theory. Okay, so now this is your NCERT question. See, coordination compounds exhibits color due to the crystal field theory, which corresponds to the DD transition. Now, in case of TiH2O whole 6, when light corresponding to the energy of blue-green region is absorbed by the complex, it will excite the electron from the T2G level to EG level, thus the complex will be violet in color. So, what happens? It absorbs blue-green color and it radiates violet color. So, that is why, or the color that is released, the released emissions have violet color wavelength, so that is why it is visible as violet. Okay. Next, anhydrous copper sulfate is white, but copper sulfate dot 5H2 is blue in color. This is also very simple. See, in copper sulfate dot 5H2 there is ligand. When there is ligand, there is d orbital splitting, there are unpaired electrons, there is DD transition. But here there is no ligand, so no d orbital splitting, no DD transition, so no color. Okay, very simple here. So, due to the heating of water, molecules evaporate and there is no ligand left. Hence, there is no splitting of d orbitals and no DD transition. That's why anhydrous copper sulfate is colorless. Now, what will be the correct order of the wavelength of the absorption in the visible region of the following? Now, wavelength of the absorption. See, the more is the splitting. Okay, if the splitting is higher, energy will be higher, right, and the wavelength will be lesser because energy is indirectly proportional, or you can say inversely proportional to wavelength. So, E is equal to, we write like this, right. So, now if I say where the splitting will be higher, if you see NH3 is the strongest ligand here, so the splitting order will be what? So, let me just show you everything. Splitting order will be NO3 minus NH3 and H2O. Sorry, NO3 minus is the strongest ligand here. So, this one will be having highest splitting. If highest splitting is there, okay, that means what? The wavelength of this one will be the least one. So, this one will come at the least, then NH3 and then H2 on the basis of wavelength. Okay, inversely proportional. Next, aqueous solution of copper sulfate gives a green precipitate with aqueous solution of potassium fluoride and a bright green solution with aqueous solution of potassium chloride. Explain these experimental results. Okay, now see, aqueous copper sulfate exists as CuH2O whole 4 SO4. Now, it is blue in color due to the presence of water ligands. Now, when Kf is added, what happens? This water is replaced with fluorine, and when KCl is added, the water is replaced with chlorine. In both the cases, the weak field ligands, water is replaced by fluorine and chlorine ion. So, that is why there is a slight change in the color, because we have different ligands here. Next, what is the coordination entity formed when excess of KCN is added to an aqueous solution of copper sulfate? Why is it that no precipitate of copper sulfide is obtained when H2S gas is passed through this solution? Very simple. When you have copper sulfate and you give CN, you get copper cyanide complex. Okay, and once the copper cyanide complex is formed, copper is already inside the complex, it is not an ion. So, when you pass H2S gas from outside, copper inside the complex cannot come out and react with the sulfur there, right, because it is a part of the complex. There is no Cu2 plus ions left here. So, that is why no copper sulfide is formed, and that is why no precipitate is formed. So, when aqueous KCN solution is added to aqueous copper sulfate solution, CuCN4 2 minus coordinate species is obtained as following. You get this compound, this complex. Now, the coordination pair thus formed is very stable, and CN is a strong field ligand. On heating H2S gas through the solution, the CuS precipitate is not obtained because free Cu2 plus ions are unavailable. Why aren't they available? Because they have now been a part of the complex. Okay. Yes, so students, these are the most important questions for your like the total physical and inorganic chemistry. If you do these questions, then definitely you will be able to get full marks in your section B and section C. Okay, if you have any further doubts, please comment down. I will definitely address to it. And all the very best. Please prepare hard. You can get 70 on 70, and if any other help is required, please let me know. And many of you have been asking about the PDF, so please join our WhatsApp channel. In the link, this PDF will also be uploaded in our WhatsApp channel. The link will be there in the description section, so please go there and upload the PDF. Like, we will upload the PDF, you download it and study from there. Okay, all the very best, and let's prepare hard for our exam.